Hello friends, good morning to another API review. Today we focus on JSON. There's at least one relatively large issue, and I think one maybe a smaller one. And I think the first one is already pretty popular, right?
Yeah, I guess I can get started describing the issue. Effectively, this is a second round of doing a design for supporting polymorphic serialization in system like JSON. Uh, some of you might remember that we had another uh, exactly 1 year ago during .NET 6, and the design at the time rejected specifically because it allowed unrestricted polymorphic serialization. And so this new proposal is effectively incorporating the feedback that was given at the time, which essentially is have a model for polymorphism that requires users to explicitly opt in every supported derived type within a type hierarchy. So I'm guessing without further ado, I might provide a brief overview of the functionalities exposed in the proposed design. The idea here is that given a class hierarchy defining effectively to get polymorphic semantics for the base type, you would need to decorate that base type with attribute, which I'm calling JSON derived type, and we're basically specifying all the derived classes that support. And when that happens, if you try to serialize an instance type derived using contract for base, then the JSON actually use the derived type without needing to specify that type statically. Uh, Scroll down a bit, please. But that model doesn't serialization because we're not actually emitting metadata over the wire. If you try to deserialize the payload using base again, you would get back an instance of type base, and you would not actually get any data written by property because that does not exist in the base type. In order to support fully round-trippable polymorphic serialization, this proposal uh, uh, recommends using type discriminators, the idea being that insert a bit of metadata into JSON, typically a string that identifies specific drive type that we're using when we're serializing the given instance. So like before, in a given class hierarchy, specifying a JSON-derived type attribute with an added argument called the type discriminator, where you explicitly say that, if you're serializing instances base, then emit base type discriminator ID. If you're serializing types instances of type derived, then emit derived type. Scroll down a bit, please. Uh, that would result in the following JSON being required. So it would additionally, in addition to all the properties of the derived type, it also emit um, a $type at the beginning of the serialization, giving the string that you specified for the given runtime type. And as an added benefit, that means that you would be able to polymorphically deserialize that value. So notice how if I deserialize something using type base that specifies that type discriminator, the return value is actually type derived. Any questions so far? Which is good, I think. Pull down a bit more. Type identifiers can be of types, can either be of string or it can be of type int, because there have been requests for supporting both types of discriminators. So in this example, I'm actually defining tags for types using values, as you would expect if I serialize an instance of derived 2 in this case, the emitted metadata would include numeric value. For what it's worth, it's actually mix and match configuration for a given type. So you can specify derived types that do not emit metadata. You can specify derived types that emit string metadata, or rather string type discriminators and different derived types that specify numeric type discriminators. And if you can scroll down a bit, please, there are a few examples pointing that out. First one, no metadata, just the properties, and the second one is some metadata. Another feature that has been requested is customizing the property name of the type discriminator, because obviously in certain polymorphic deserialization scenario, you might not control the schema that is given to you. Dollar type might not match your use case, you might case or something different. That can be specified using JSON polymorphic attribute. Essentially controls facets polymorphism configuration not specific to individual derived types. So in this case, I'm specifying the type discriminator name to be case, and if you scroll down, you might see an example of how that changes serialization. Moving on. Please. Consider the following type hierarchy. So we have a base class and we have a couple types deriving from it. But in the base class configuration, I'm only opting in polymorphism for derived type 1. I'm not specifying any polymorphism support for derived type 2. By default, what that means is if I try to deserialize as base instances of derived type 2, that would throw exception. But it might be the case that users change that behavior. And this is controlled using a new enum known as JSON unknown derived type handling. Hey, Mariam. Okay. So I was saying that unknown derived type handling can be tweaked. JSON unknown derived type handling enum, which can be specified in JSON polymorphic attribute. One option, a bit to the right, Nemo. Fall back to base type, and that basically indicates that if I'm trying to serialize unknown runtime types, then basically just use the contract of the base class. There is a second option other than the default, which is fall back to Ancestor, and this is, I guess, a bit more interesting. In this case, if you have a class and a derived class that has been opted in, and the runtime type that you're trying to serialize derives from that type is not opted in, then it would cause serializer to nearest ancestor has been opted. So if you scroll that code snippet to the left, it may go. So I have a class called test class deriving from my derived class, which is this would cause the serializer to act for my derived class, because that is the nearest ancestor that has been. Does that make sense so far? Okay. One thing to note about the third option is that it the complication, and that complication time, and then scroll down a bit, please. I have an example of this. If you define polymorphic interface, it is actually possible, then it is likely, so there is a small mistake in this code, but it is actually likely that there is ambiguity what the ancestor is. So assuming that my derived interface, my derived class are both in for polymorphism, it actually turns out that there is a back to what the nearest ancestor of this class is, in which case there's nothing we can do. We'll just throw supported exception. And that is more or less kind of the core function that's being exposed here in a nutshell. This is all the configuration that can be done via the attribute, but obviously there have been requests for use to be able to configure polymorphism via the contract model has just been approved and is currently under development and will be shipped in .NET 7. So there is this upcoming concept known as the JSON type info resolver, which can be used with metadata. If you can scroll down to this to the following snippet, you can see that it's actually possible to define your own type resolver, and metadata for individual types can be polymorphism using the new polymorphic type info property, which is null by default. Might be a question, Stephen?
Stefan?
Yeah, sorry.
Stefan.
Off in the middle, so sorry about that. But kind of like broader, it's just about like JSON polymorphism in general. I know in like normal APIs in ASP.NET, and I think also in MVC, when we realize objects inferred from actions, basically like controller actions or delegates, we serialize it as objects, right? So we get like all the properties, like fully polymorphic, right?
Yep.
And so I get that here, but did ASP.NET change what it's doing? Is it bad to just serialize objects? Like if that's the expectation that developers have, we tell developers just to use custom DTOs if they want to hide properties or whatever.
Yeah, I mean, according to the conclusion reached during last year's review of polymorphism, that behavior is actually bad because it could result in accidental data. But that behavior, such cannot change it. So for this particular feature, which is, I would say, an independent way of doing polymorphism, we are explicitly avoiding that path of unconstrained polymorphism, any possible runtime type that could reside from that you're trying to serialize.
All right, thanks. Yeah, I just wanted to gauge like that awful, kind of reasonable, but just be very clear in the documents.
I think you're right. I guess I was saying that in the upcoming JSON model, it should be possible under this proposal to modify polymorphism metadata on the type metadata itself, and that possible a new JSON polymorphic type info class that follows a fluent-ish API for opting in derived types, either passing or passing type discrimination. And that is more brief overview of API. Are there any questions concerning features so far?
So just to be clear, like in order to opt in subclass types, that opt-in mechanism has to be either through programmatic config or specified on the base class itself. Like derived types can't go opt themselves into the system. I don't even know how you would find that on it.
Right. It's kind of intentional that only base type can specify its own, and that polymorph is inherited by types or vice versa. So if you have a derived type that is polymorphic, that is not consulted when specifying polymorphic.
And you think that in cases where, for instance, I don't control the type hierarchy because maybe it comes from a separate library, then this programmatic config is the solution?
Right. Yeah.
Okay.
The current behavior, if you say serialize as base and give it a derived, is to serialize the derived instance with the properties from base, right?
Right. Yeah.
So now on the base, you apply a polymorphic known derived type, not include type. Serializing that now starts to throw an exception.
Right.
Okay, just making sure I understand the before.
Unless you change the known type handling. But I kind of felt that showing is a good default because it likely might indicate trying to serialize something that you missed polymorphically.
Yeah, that sounds reasonable to me.
Right? And I guess unless there's any questions about the examples, I think we can move to the API proposal a bit further down. Yep. So I guess I can start with a JSON polymorphic attribute. That is the attribute that kind of specifies hierarchy-wide configuration. Currently, it exposes 3 properties. As mentioned, the custom type discriminator property name. If that is left unset, default, which is $type. Ignore and recognize type discriminators. That is a knob specifically concerning deserialization. The idea there being that if I try to deserialize something and the value of type is recognized string, the default behavior is to throw, but might be conceivable that we want to ignore. And in such a case, we would actually try to deserialize using the contract for the base type. And then finally, there's the unknown derived type handling property, specifying the different values described in the unknown derived type handling enum, which I guess we could, I could present now at the bottom page. So if you look at the JSON unknown derived type handling enum, it has 3 values: failed serialization, default, fallback to base type, and fallback to nearest ancestor.
I had 2 quick questions on this. The first, when you say that you fall back to base type, does that basically mean that you pretend the $sign type value simply didn't exist at all?
So
Is that effectively how that works?
so that enum governs serialization.
Okay.
Maybe that's not very clearly communicated in the naming, but the bool governs deserialization, the enum governs serialization.
Okay, got it.
So
And you have, oh, sorry, talking?
I was just me. Like I was just wondering, you have fallback to base type and you have fallback to nearest ancestor. Should it be fallback to nearest base?
I'm happy to. I'm not necessarily the biggest fan of these, so I'm happy to make any suggestions to improve.
I feel like the difference was Ancestor included interface hierarchy and base type includes just the one declared in the T for serialize.
Is there a reason that we would actually want different behaviors here? Like, is there, if you say T and you pass a T derived, T derived is acceptable, but T derived is not. Like, is there any reason that we shouldn't just walk up until we hit the closest parent, even if it is the base? Like, why have 2 different behaviors?
Because there could be diamonds if you're falling back to the nearest ancestor. I mean, granted, that's specific base hierarchies, but that possibility of you getting an exception kind of tells me that just falling back to the base type is behavior that some users find desirable, depending on the application.
So you would, interesting. So if someone passes you a concrete type, you'll consider the interfaces when looking to see, is this interface serialized, marked as serialized?
Assuming they're part of the hierarchy relative to base type you're base, probably the appropriate name here, but the root type maybe also not right.
Sure.
Yeah, you get what I mean.
Yeah. Okay, no, I see the scenario then. So my second question was regarding the JSON derived type attribute. Do you have to specify the string or the int for deserialization to take place?
Deserialization should still work if you don't specify them, but it would always use them.
I'm sorry, I meant like if you say JSON derived type attribute type of derived, like we infer a type discriminator ID if you don't specify one?
We don't. Not specifying one means that none will be.
I see. Is there any reason that you would not want to infer it just from the type name itself?
I kind of feel that there's ambiguity there concerning namespaces and, I don't know, assembly qualified names, and I'm guessing we're stepping into dangerous territory once we start considering using auto-generated identifiers for types.
Oh, sorry, I didn't mean like the namespace or the assembly qualified name. I meant literally just the friendly name of the type, everything except the assembly and except the.
I mean, we could do that, but we still need an entry point for people not wishing to emit any metadata, and it kind of felt that
So the first constructor on that edge have no number or name. Basically, that means don't throw when serializing, but always deserialize as the base. Or sorry, serialize and deserialize base.
No, the first one means serialize as the derived type, but do not emit any metadata. So whatever properties exist in the derived type, serialize these, emit them over the wire, but do not include any type discrimination, which is actually a valid scenario. Like you might have a type hierarchy that models a view of some sort, and deserialization is not a requirement, and as such, having metadata emitted is undesirable.
Yeah, in my case, for example, look at syntax nodes that in compilers often have. They have a kind property that already specifies what you would switch over, right? So you already have effectively all the metadata that you would want. The only problem is, I think, with that model, like, I think you would want some sort of mechanism to use those properties to determine which type to instantiate on deserialization, right? Which I think in your world would be, well, then you have to extend the contract behavior, right?
Yeah, I would probably say that that might be a concern solvable via Christoph's metadata customization.
Would you be able to say custom type discriminator property name was kind, and then just use all the kind values in the type discriminator? Or would that say you can't, or would that fail because you can't use a custom type discriminator property name that matches a property that would have come off the object?
Probably. Yeah.
So to answer your question, the last part of the question, they're specifying a type discriminator that conflicts with a property name. That would not mean that deserialization of that conflicting property would not be taken into account. That name would be dispatching to the right conversion.
Which sounds like it could solve. Presumably, those objects don't have setters on that property.
It might.
They just report this is who I am. So
yeah, it ultimately it also depends on the position of the property. Like obviously, if the kind property were inserted at the end of the JSON object, then then actually happen. Like it actually, the way that metadata reading is like JSON in general, and we have metadata for other scenarios as well, is that they require that they are inserted at the beginning of an object. So as soon as anything, so as soon as you get to the point where you start reading regular property names, then metadata parsing finished, on to read the actual object payload. And as such, no polymorphic.
Is that necessary?
I think so. Like otherwise, you store all the intermediate properties that you've been reading, and we simply haven't written our metadata infrastructure. I kind of thought about maybe offering a way to do this, but I couldn't really come up with anything that practical.
So, but like, okay, let's say I have my handwritten discriminated union, right, which is similar to, let's say, Roslyn's syntax nodes, right? We have a kind property with an enum, right, and then each derived type, returns a fixed constant effectively. In order for me to serialize this, now I would basically have to do two things. I would first say I would have to mark my kind property as JSON ignore effectively to say don't serialize it, and then every time I basically, basically would have to apply an attribute to each of my derived types, repeating this constant effectively, which in my case would be an enum. That would also be interesting. Like, can I even have an enum in here, right? Because I would have to force it to be a string, I guess. So I could say name of, enum.member name, I guess. And then I would probably give it the same name that the property would have had, so that the thing looks somewhat reasonable in the serialization form, right?
Yeah.
I mean, I guess that would work. It's just it feels a bit. I have to repeat myself quite a bit in this design.
But the attributes you apply would not be on each derived type; they would be on the base type.
Sorry, that's fair enough.
Yeah, I mean, I don't believe we would be able to, how do you say? I don't think we'd be able to support every single scenario. It's an opinionated design in many respects, and one of the ways that it is opinionated is it has a very specific understanding of what a type discriminator is, and if
Right.
that somehow deviates, then unfortunately we won't be able to support it. Somebody might say, the discriminator is actually nested in a JSON array, and could I please have a way to obtain the metadata from there? And the answer is no. Unfortunately, you need to write your own converter to get that scenario working.
Yeah, I was just trying to think of, like, simple cases where I have my own polymorphic types, right? And I mean, I think in any scenario where you need to deserialize, you need to be able to somehow tell from the payload what type to instantiate, right? And there's only really two ways of doing it. One is there's a custom tag, which is basically what you're proposing here, or there's existing data on the thing that tells me that already, right? And yeah, I understand you don't want some sort of like, oh, if it has these properties, use this one. If it has those, use the other one, right? But it seems it's a very common thing to have a known kind property or something like that already is the tag effectively.
I mean, my recommendation in that case, you have, say you have a domain model, is kind of peculiar. My recommendation is, use a DTO model that does this in a way that is conducive with how given serializer, and map your domain model to DTO and serialize polymorphically that way.
Sorry, you're basically saying duplicate your type hierarchy?
Yep. Best practices.
Oh.
So with fallback to nearest ancestor, my recollection, Tyler lifts all interface declarations onto the type, all the ones that it knows about when compiled. So how are you determining
Section.
Sure, but what's the degree of
It basically means walking through the graph of supertypes above the current type and determining which one is the nearest. Nearest here being kind of the distance in a number of hops sense.
right? But like if you look at something that is IEnumerable T, it'll probably only declare that it's IEnumerable. But if you ask what interfaces it implements, I believe it will say IEnumerable and IEnumerable. So it will show them at the same level, even though there was in a hierarchy there. Are you just manually building the? If I see that this was derived from some other interface I already had, I'm increasing the depth count.
Basically.
And then if a base type I sum interface and then the derived type explicitly redeclares that it's I sum interface, where do you count that? Or if it doesn't, is that you say this must have come from the base, so it's below the base type, or is it conflict with the base type and sorry, equal weight with.
It's been a while, and I need to reach, but I have taken into account that.
Okay, like these are just I at an abstract level, value of assuming somebody thinks that interfaces are worth marking up as far as their polymorphism behavior is concerned, but I wonder if it's a thing that people can reason about, and maybe I'm just too up edge case.
Well, I think in practice, what will happen is people will just derive one hop, right? I mean, this is the old person and then person with internal details derived type, right? And you would just say, yeah, just go back to the closest one, which is usually just your parent.
If we took interfaces out, like if we said interfaces never count.
Yep, obviously.
So it's sort of a, do we need interfaces?
Don't need them.
I mean, it depends on, I guess, what you want to do here. I guess if people want to deserialize with interfaces, then I think in practice they will do what I just said. They will effectively have a simple inheritance hierarchy exposed over interfaces. I think when people use this with interfaces, they're not very likely to have graphs. And if they do, well, we can make the behavior well defined. It might just be surprising, but I mean, it's just code, right? But yeah, I mean, if I were to use it, I would not have a complex graph and then configure nearest ancestor and then ask myself what I think the answer is going to be, right? But for some reason, people like interfaces.
What it's worth, like I think you can concoct like pathological hierarchies. The answer would be surprising given the current implementation.
Yeah,
but
for sure.
I agree with most point that basically the scenario we're looking to is people want to serialize something as derived type foo, but the actual instance, some private derived implementation. We probably wouldn't want to block that type of scenario.
Okay. Yeah, as long as we think people can reason about it, or that we expect that either if you put them on an interface that basically that is the T for serialization, and that it's like, and that then 2 and 1 become hopefully the same behavior.
I guess I have a question about naming here. Clearly, term base type is abuse of terminology in this case, so I'm kind of wondering if we can collectively come up with a more appropriate.
Right. So the value 1 type handling, whatever T was specified in the angle bracket, right?
Correct.
What's the name of when you don't use the generic and you pass in the type object parameter?
Value, but it might not be the root type you're serializing. It might be a property type in some nested POCO. So it's basically the member type that you're serializing in your.
I think you could probably say fallback to static type.
Yeah, or declared.
Declared also works. Yeah.
I like that.
It's the declared type if it's a property, type that you declared as the serialization root. Otherwise, so declaration always happened.
Like that. What about nearest ancestor?
You could literally call it declared, the nearest declared type, right?
Well, but nearest declared is. So I can't, if it's also going to try and interface based matching, then I can't think of a better thing than nearest ancestor. I mean, you could call it nearest type, but it's a nearer type. It's nearest ancestor type. That feels. I don't think the type adds anything there.
Yeah, I kind of agree. Like, I mean, in general, when you look at a graph, like, term ancestor and the DAG is also kind of weird, but I guess it is what it is.
I mean, what about super type? I don't think we use that term, .NET at least, but
I don't
it's
think we use
the
it anywhere.
commonly accepted term. Okay.
Yeah.
I think that's kind of like Java's version of
term.
base type, right?
No, it's a super type could be an interface as well. It's basically a type theoretical. So it might be an interface you're implementing, or it could be your base type. It basically means that you can downcast to that thing, upcast. But I don't think I've ever seen that name being explicit.
Yeah, because type just uses base type. It uses implemented interface.
Yeah, super supertype appears in none of our ref CSs. All the supers I see are superset.
We do have subclass.
Also superscript.
So type uses is subclass, which means that it's derived from the specified type.
Yeah,
So
we've never used supertype or superclass.
we could say nearest subclass.
Well, but that's the wrong direction, right?
No,
That's
yeah,
the-
that's wrong. Directions are hard. Can't follow.
I mean, I could also live with base type because realistically, like even if you use interfaces, you kind of think in those terms, right? I mean, if you do a polymorphic hierarchy where you implement multiple interfaces, then well, yeah, there is a definition, but it might not be the one you intended.
I mean, I do think we call it a base. For in an interface decal, we call it interfaces.
Yeah.
Type saying that it implements base is a foofy use of base, but I guess that would be the nearest base type, and it would someone think interfaces aren't included. I think if we say something weird like nearest ancestor, then it just makes you stop and think. It's like, oh yeah, interfaces count.
Yeah, either one works for me. So one question I have is you call it type discriminator ID. ID seems a bit odd. It almost seems like you want more like value here because that's effectively the value you use for the type discriminator property name, right?
Yeah, I kind of figured that a type discriminator is kind of the concept that defines your effectively discriminated union as you serialize this thing. The ID is the value, and I kind of agree that they might be for those.
I mean, value might also look weird, but yeah, I don't know what this.
Yeah, I mean, it is an ID.
Yeah, I guess.
Oh, it ID value, but that just. I assume that when you're loading the type, if you see same discriminator applied times, you get angry. And since you take numbers, the number 1 and the string 1, are they the same thing or are they different? Okay.
Yeah, I assume if you pass a string, we put it in quotes. If you pass it int, we just assign the number, right?
Yeah, it changes the underlying JSON type.
But on deserialization, you're not going to sniff. I didn't find the thing that had a number, so let's go look for the 2-string version of it.
No, that's happening.
Okay.
So very intentionally using only ints and strings and not using JSON numbers in general. People think that there might be need to expand this.
What? No support for floats or doubles or halves or daytimes?
So I'm curious, like, what happens if you have two interfaces and they both define the discriminator, and then you derive from both interfaces?
Exception.
Okay. So like in any case where we could basically think of like one or like where two discriminators could be used for the same type, that throws an exception. Like even if I use the two different discriminators. Yep.
Yeah, so I guess that more or less covers the attribute API design. So the second component is basically surfacing equivalent functionality for the metadata APIs.
So one thing, I mean, on the JSON polymorphic attribute, is there any value in naming it custom type discriminator property name? Why not just call it type discriminator property name?
Yep, fine with that.
Like it's custom and you specify it, right? If you don't, then we default it. But
Yeah, I guess that was what I was thinking when I added custom in front. But it's an attribute, so it doesn't really make any sense, does it? Yeah.
Well, yeah, you either specify it or you don't, right? It will, like you see whether somebody specified it or not.
Shorter names are nicer. Right. So should we move on to the metadata APIs?
So what is your default for ignore unrecognized type discriminators?
False.
And that means you just
Throw
an exception. I see. Seems a bit weird to call it ignore though. Ignore seems to indicate you just move on. But that's
if you said it's true.
Oh, sorry. Okay. So what does that now mean? Like you basically return null? Or the base type?
You serialize using.
Gotcha. I guess that's the best you can do, right?
I mean, we could try future proofing this and making that an enum as well, but for the life of me, I couldn't think of other configurations that might be possible here, so I went for the simple option.
I mean, the only thing I could think of would be that it took a delegate, which specified an attribute.
So isn't like the property that you specify after controlling what happens when you don't recognize it? Like how
Sorry, could you repeat the question?
So how is ignore unrecognized type descriptors different from unknown derived type handling?
So
yeah, they probably need a way of better marking that one of these is only deserialization and the other one is only serialization.
Oh, yep. I see. Okay. I see. I understand now. Okay.
I mean, like, we could go deserialization, ignore unrecognized type discrimination. Serialization, unknown derived type handling.
Never mind. It makes sense now. Like,
if we think it's handled by docs.
Yeah, my expectation is that docs what the purpose of each of these knobs is.
Yeah, it would be nice if the names somehow connect them together and one is in, one is out kind of thing, right? But I don't have any great suggestions. I was just thinking they control the same thing in different ways, and I'm like, it seemed to be the same thing to me.
Yeah, I mean, like, I can agree they sort of make sense in their context if you look at them. Like, when would you see an unrecognized type discriminator? That wouldn't be on write, because on write everything was specified. So you could only unrecognize something on read. And then an unknown derived type handling, well, you only know it's a derived type if you're serializing.
Yeah.
So
yeah, as I said, I don't have
the
any.
names don't jump out at you. Like they do. There's enough description of what they're doing that if you stop and think about it, it makes sense. And again, docs probably say, summary on deserialization, comma.
Yeah, I agree.
Unless there's a really concise way we could get this in enum name and then make deserialization an enum as well with an equivalent name.
I would say
can't think of anything.
your summary should probably just start with upon serialization, when an unknown derived type is encountered, do this, right? And then upon deserialization, when an unrecognized type descriptor occurs in the input, blah, 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 then I think it will be pretty obvious.
Right.
Yeah, I think I don't have any comments on the serialization thing. Does anybody else have anything else?
I'm good on the attributes. And these are inherit false.
Yep.
Yeah.
Is there a reason you're excluding structs?
It's a bit weird to have derived structs.
Just normal brain, look at the C-class interface, ask about the third one.
Yeah, it's all good. You're welcome. I have one high-level question. Like, I assume the design is kind of similar or orthogonal to what JSON.NET has been doing.
It's a very different beast.
Do we have any opinions on like how easy is it for people to move from one to the other? Is it like brain surgery level hard, or is it like, yeah, just a few different names and
you might need to remodel.
I see. That's unfortunate.
Like this is a very an intentionally opinionated implementation that is very intentionally constrained as well. Maybe rewriting your exaggeration. Like, clearly, you need, it's not like copying and pasting from Stack Overflow type of solution. Might need to think about things.
So what's the high level difference? Is like JSON.NET like callback based? You sniff the payload, you decide what to do, or?
So if I recall correctly, it's basically type binder. This system.type.getType on ID and go nuts.
I see. It is kind of callback based in that sense, yeah.
Yeah, I mean, for what it's worth, that's explicit surface here.
Yeah, and assumed all of this will just work fine with source generation as well, right? Because it's all statically typed.
Correct.
Yeah.
Source gen works with the attributes.
Yeah.
Eric, if you configured it programmatically, do you need to remodel your DTOs, or would you be able to use the same DTOs?
So the programmatic configuration follows the attribute model. So I'm not sure what you mean.
Sorry, if you said, I think somewhere else in the proposal you had said like JSON config type of my base type, also allow derived types, type of derived one, type of derived two, and so on. Is that not something that is an option to using attributes, an alternative?
It is it's posing the exact same functionality without needing attach attributes. So it's the identical set of knobs. I got the question right.
Yeah, so but that means, I guess, in theory, like I could, if I didn't want to touch my details, just do everything programmatically, not applying attributes.
Absolutely, full one-to-one correspondence knobs here.
So you have a width on screen. Is it returning this, or is it returning a different?
It's returning this.
So do we need it to be fluent? See, also, we generally don't do fluent.
I don't know. I kind of start by what entity framework is in space, so it kind of feels natural to adopt the same pattern. And I'll go through the details here, but basically there's an untyped JSON. There's an untyped fully optional strongly typed configuration. and it kind of validates that the derived type that you're passing is actually deriving from the base type, and I think that's like unlike attribute, actually validate at compile time that this is an actual type hierarchy that you built.
It looks like somebody built what you just built for JSON.NET. They call it JSON subtypes.
Right.
Which works the same way. Basically, you specify JSON converter, and then you give it the name of the property you want to use, and then you say JSON subtype is known subtype, and then you give it the type and then the value for the thing. So it's exactly the same way.
I think we should come up with a different name for the configuration class, because the type info in the end suggests this implements JSON type info. I think. I didn't know what other name would use though.
JSON polymorphic types.
Or maybe JSON polymorphic configuration, something like that. But like I wouldn't put type info because it's like suggests it implements something else.
Yeah, I agree. My first instinct saying it was that it was a polymorphic type info. Polymorphic type. Previously reviewed the type info.
How about mapping? Like it maps the derived type to a discriminated ID, right?
Yep.
JSON polymorphism map.
Yeah, I guess
JSON derived types. JSON derived type info.
Again, ending in those 8 letters makes it seem more like JSON type info, or a type that derives JSON instead of an augmented JSON type.
Possibly something like allowed derived types.
I mean, generally, I would assume plurals and type names are always weird, so I'd come up with a name that is a singular.
I would say that if you were to parenthesize JSON type info, would put parens JSON type close paren info rather than JSON open paren type info close paren. So type info is a thing that you need to be consistent with. JSON polymorphic type is a thing. Type is a thing. There's a suffix indicating that this is metadata.
Yeah, but I mean, instead of polymorphic type, it could just be polymorphism.
So you would name the type JSON polymorphism?
JSON polymorphism info.
I mean,
that works.
It is polymorphism info, but it's bound to types.
Yeah. The polymorphism info for some type specified in the constructor.
How about JSON type discriminator info? Then you have discriminator in between.
It's optional.
Then I'm out of ideas.
But I mean, like, you know, just mirroring Christoph's thing. When I saw in the sample line of code something about new JSON polymorphic type info, I was like, oh, this is like where we had the fallback type info and the concat type info, and this is some new kind of type info. So like that's
again,
the parentheses in my head, JSON open paren type info. That's where it gets weird to me.
Yeah, I kind of agree. Like, I mean, there is this convention, right? If we have an abstract base type, and then there is derived types that have that as a suffix, or other types that have this as a suffix, you kind of assume that it is a derived type, right?
But it's JSON polymorphic type info. polymorphic JSON type.
Sure, but I think that's a bit splitting hairs. I'm not sure
Yeah.
that shows up.
I mean, it could be JSON type polymorphic info, type polymorphism info, JSON type polymorphism, JSON polymorphism info. I don't know. Like I see the logic behind the name, and if we hadn't just approved a thing called JSON type info like last week, I'd be like, it seems like the best name. It just, but with the recency of experience, it feels like obviously this is a custom type of JSON type info, and it's not. It's a property that modifies a JSON type info. It's a type property that.
For what it's worth, the original name and the prototype for this is JSON polymorphic configuration, but I guess any type that has configuration as a suffix loses points for originality.
We're conventions and standards based. Don't like originality.
So JSON polymorphic configuration then, or JSON polymorphic type configuration?
Configuration
What does
seems odd, but I think map or mapping or I mean even JSON polymorphic
type map.
I mean I could even live with JSON polymorphic info, to be honest. Like
Maybe JSON derived type option.
Options. For what it's worth, it is implemented by a collection, so perhaps the name should somehow reflect that. So JSON derived types, one possibility.
yeah, I think even collections don't have plural names usually, right? They're still singular names.
Yes. The collection is a set or a dictionary.
Yeah, we come up with a name that is a singular, right? I mean, we have used plural names before, but it's always weird. Especially when I have a list of those things. It's like, how do you call those?
I mean, is that an issue if we're dealing with a very domain-specific collection? JSON has been doing that for what it's worth already.
Well, yeah, I'm saying, as I said, like, it's not that we haven't done it. It's just, it can result in oddities, right? But yeah.
I mean, I know that we feel like we use options type name, which is a plural, but really that's just we're saying this is a collection of the bag of individual named options.
Yeah, I think his point is that this is the same here. It's a collection of derived type to discriminator ID, right? But I think for the most cases, like we either call it a dictionary or map or mapping or something like that.
For what it's worth, it is a bidirectional.
Yeah, which we don't have in the BCL, so I guess map could actually be the name, yeah. But you don't expose query APIs for either way, right? Just internal, I guess.
I don't think it.
No, I'm not saying it needs to. It's just, for the user, it's not material really, whether it's bidirectional or not.
Plural types mostly look like options and settings. Permissions is a namespace.
Yeah, and we can also take it offline, right? We don't have to come up with the name right now. I kind of agree with Christoph, though, that type info seems like a bad choice. I just don't know.
I mean,
something else right
JSON
off the head.
polymorphism. It's configuration sounding like it came out of a text file. Same as options. It's a word for a bag of state.
So in general, we have a bunch of option suffix classes in perhaps for the sake of consistency. We should be using options instead of settings here
Okay.
as well.
So JSON polymorphism options.
Yeah.
Sorry, say this one more time slowly.
Replace type info with options.
Polymorphic with polymorphism, right?
No, I don't, whichever way.
Polymorphic, but I'm bigger.
Yeah, I would also go with polymorphic options because polymorphism options is like, oh, that's a bit much.
JSON
Well,
polymorphic options. Sorry,
it's the difference of one letter. Basically, it versus SM. So C versus SM. But I think polymorphic options sounds like it's describing that options are polymorphic, whereas polymorphism options says that the options for polymorphic. And so I much prefer polymorphic option.
Or just derived type option.
I was about to say, do we need the name
Yeah.
polymorphic at all? I mean, because it's the only place we
Sure.
use it, right? And everywhere else we refer to it as derived types.
Yeah,
there's
derived
also
type is better too.
there's a JSON polymorphism attribute, JSON polymorphic attribute.
Oh yeah, that's true.
So where is it?
Isn't that the base type basically?
It would be like JSON allowed derived type. The other one would be allowed derived type.
I like JSON polymorphic. Fairly simple and consistent with naming conventions.
Is JSON polymorphic attribute bad?
So the reason why I am second guessing this is like, it's not a word that is like, you know, super easy, right? And it doesn't really describe what we do, right? Like JSON derived type is pretty obvious what it does, right? It declares the derived type, right? Polymorphism kind of means you need to look up what this means.
It means many things as well. That's another thing.
That is also true. So yeah, I would be supportive of anything that avoids the name polymorphic or polymorphism entirely in this feature and just.
Well, but then the thing that says what's the type discriminator property, like, what would you? We can't use JSON derived type, so it'd be JSON derived type configuration. Like, we call it the configuration attribute. Sorry, we weren't calling it options. JSON derived type options attribute.
I mean, you could literally call it JSON type descriptor attribute, right? Because that's really the only thing it configures.
Right, let's.
It
feels like maybe we should see what we want type to look like, and then we can go back and see what we think the attribute does after.
For what it's worth, I initially wanted to avoid using the term polymorphism, and that's why the users actually called type hierarchy. But as good a name that is, I necessarily make that mouthful fit in actual API.
Well, I mean, you don't have to always say it, right? I mean, like, as I said, you could main the attribute JSON type descriptor attribute. The other one is called JSON derived type attribute, right? So it seems like a relatively easy thing. And then this thing you could call like JSON type descriptor options or JSON derived type options, right? That
How would you
work.
How would you type that supports derived types in the context of?
Okay, I mean, where would you need to use this?
Because I'm guessing that would be a component of attribute that you put on the type that is specifying derived types. Specify additional.
Yeah, that attribute I would just refer to it as the type discriminator attribute, but
But it's not only, it's specifying a bunch of things. And I mean, currently it exposes 3 options that 2 of them pertain to type discrimination. The third one does not. So it's configuring a bunch of stuff related to type hierarchies. So I mean,
Call it JSON type hierarchy attribute.
that's not bad.
type of type hierarchy attribute.
I think Eric was just joking.
I was joking. I guess my conclusion at the time was, as much as I wanted to avoid polymorphism, I couldn't come up with a more concise way to describe a type that supports type hierarchy.
I mean, you could also call. I mean, you could also go the XML route, right, and call one of them a base type and the other one the derived type, and like that is also not terrible.
So like JSON base type attribute.
Yeah, and then the other one is JSON known derived type attribute, for example, which is what the other guy has been doing, and that's I think also what XML is doing. I think it's called known derived type rather than just derived type.
I like that.
It's known type attribute.
Or known type attribute, yeah. But the key is that you basically say known somewhere to point to the other thing.
That JSON derived type seemed fine for the concept.
Yeah, it just seems weird to have them on the same type and you call one JSON base, the other one JSON derived, but I guess that also works.
I would personally rename the derived type JSON derived type to allow JSON or allow JSON derived type or something like that, because this explicitly tells you I allow this to happen rather than like declaring something declaration. But
I mean, attributes don't change the type hierarchies that an assembly contains. So I don't see how people might misinterpret this as something.
Okay. So what are we talking about? On screen, I see the polymorphic type info, but we're talking about the names of the attributes.
I'd say we're talking about the name of the one would probably influence the name of the other.
So what I have been hearing, so like let's just do one step at a time. The thing that we have on screen right now, I think people expressed a preference for calling it JSON polymorphism options. Is that right? If we include the name polymorphism somewhere, right, or polymorphic somewhere, then that would be the name you would give it, right? So then I think, so okay, then let's book this in. So we have that. And I think then the next step was, okay, can we get rid of the name polymorphism entirely, or the terminology in this API entirely, and just try to describe what it does rather than using this big word? And I think Eric brought up the problem that, well, it's a very concise term. And so if you have to use it with something else, you can easily do that. If we come up with a description, then that might be harder, which I agree with. I mean, it's certainly easier to Google. I think the problem is, though, that if you were to use this feature, would you know that that's the thing you need to Google for? I think people like us probably, or people that build compilers probably, people that have drunken the OOP Kool-Aid maybe. I think ordinary people would probably look at something like JSON and derived types or something like this, or JSON and type hierarchy or something, right? That's probably what they would search for. And I think it would be nice if we could somehow use those terms here, so when people see the attributes, they're like, ah, that's what that's for.
I mean, JSON type hierarchy attribute doesn't sound it might. I'm not necessarily sure that people might be able to understand what it does just by looking at the name, but maybe I'm wrong.
I mean, I think if you call the property or something like allowed derived types, while I don't care that much about the type name, then that kind of, okay, this is a collection. You know, you can add direct type, and it's kind of self-explanatory. Yeah, I really like the allow in the name. Got it, but might be in minority here.
I mean, just having some attribute that has the word derived type in it, I think is probably good enough for people to like stumble into the right direction, right? I think the trick will be like once they try to use the attribute, it's like, well, what the heck is the type discriminator ID? And then if they try to apply this thing, probably what most people will do is they apply, this attribute multiple times, specifying a derived type, but not specifying a discriminator ID. And then they're really confused why stuff doesn't deserialize. That would be my guess. And at that point, they start reading the docs. And then the docs tell them like, oh yeah, you have to do various things actually. You have to apply this other attribute. You have to decide what your discriminator ID property is. You can use the default or the one you can specify it. And then you have to come up with values for each of your derived types because you have to burn into the JSON, right? I think that's probably not much we can do in the API to help people with that. I think that's just a concept they would have to learn.
Yeah, for what it's worth, I'll say that much of this design was influenced by what Entity Framework is doing, and they call their feature inheritance or inheritance hierarchy. But the name hierarchy doesn't actually survive in any of the APIs that they're surfacing. Like they are using the term type discriminator, and they use they don't use derived types per se, but they use type discriminator. Different names in the API that don't necessarily point back to the overarching feature with inheritance hierarchy.
But do they have a similar
Sure.
design where you put attributes on the base pointing to the derived?
No, they actually only use.
I got. Yeah,
At
I see.
least that's what.
I mean, come to think of it, I think you have at least one attribute that has a name people are fairly likely to look for. And then from there on, they can discover the docs. I don't think that's an example where IntelliSense will make people successful no matter what we do, because it is a thing you need to probably learn. And so maybe it's okay that, they may not know that JSON polymorphic attribute also has to be applied, but once they see the docs for JSON derived type attribute, there's a remark section that has a sample in it, and hopefully that will be self-explanatory at that point. Are we then happy with JSON polymorphism options as it is on the screen right now? Do we like the I collection of tuple?
No, that's why I wanted to know what we were talking about. If we're talking about namings of attributes, I wasn't here yet. So why is it a collection of tuples?
As opposed to?
Well, like why is it a collection? And if it's a collection, so you can use the collection initializer pattern and get rid of all the widths. Also, the fact that it's I collection of object question mark. Now because you're not controlling your adds, can add it. You could have done it explicitly. You're allowing someone to call add with a thing on an interest string.
That would. But you're right that it kind of opens up an insertion API that doesn't have the guardrails of the method.
I mean, it seems like you're not exposing anything. Like, I assume all the methods on the interface you implemented explicitly, right?
They're explicit.
So then, why is it I collection of anything in the first place? Do you want the like?
So, I'm guessing that that's surviving from the time when this would be a thing attached to JSON serializer option, and we are exposing these things as I-lists and I-lists. I don't think, to be honest, I don't think that needs to be part of the public API. People might have a need to enumerate the things that exist for other reasons, but not for the core use cases that we're interested in here.
Yeah, I mean, if you want an initializer syntax, I think, or some nice syntax, I'd rather go for INumable of either a key value pair or your tuple, and then have rename the with derived type to just add, and then people can only do the 3 things you have here, nothing else. There's no add with daytime.
Yep.
I think that would make more sense then.
But again, it also seems weird because you like JSON polymorphic type info dot add, and it's like adding.
Yeah, I
Sorry,
mean,
JSON polymorphic settings dot add. So it does feel like you want add type.
I mean,
so with becomes add and void return.
And as a general principle, right, if you have a type that records information, I want to be able to get it out, if only for debugging purposes, right?
Right. So, like, yeah, type could be IEnumerable of this, I guess. But I don't know why. I'm questioning why it needs to be a collection. Like, if the purpose is to use object initializer, collection initializer, then
And you might
maybe,
want to get the number of types, which basic INumable be able to give it to you.
Right.
Yeah, but I feel like we have a thing that says don't use collection if you just wanted to count.
You use iRead-only collection.
I think in order to get collection list, the syntax work in C#, the only requirements are you need to be INumable and you have to have an add method.
Right, but it being called JSON polymorphism option, to me that doesn't make add seem obvious what you're adding.
That's true.
And
Because
also,
it's not a JSON derived type collection settings. Now, adding a set first thing is a type. That,
I mean, in fairness, you
sense
do get the parameter info, right? You get add and you see derived type and you see type discriminator ID, so you kind of know what you're adding, but yeah.
right,
correct. Correct me if I'm wrong. Object initial an API based on object initializers would be inconsistent with the statically typed variant below, right? Like would
we're
that?
not there yet.
Well, yeah, we would mirror this over the other, right? So I guess whatever decisions we're making here, we would make them uniform.
Yeah, like I think it's fine to have a property hanging off of this, which is an IEnumerable. You want an iRead-only collection of the derived type and the type discriminator, but I don't think that the type itself should necessarily be enumerable.
Yeah, that's actually a good point, because this is actually specifying more than just a list of things.
Yeah, that one I agree with. Like, I think I mean, in general, like if you call something options.add will always be somewhat weird, unless it's a key value pair, you know, of option name comma value, right? Then maybe, but yeah, it's a bit odd to mix them here. So maybe just give it.
That mean that with derived type would also need to be nested into a different thing within options class?
No, I think you could have in the class, whatever name it gets, we can have add derived type, and that adds it. Have a property that's IEnumerable or iRead-only collection or whatever makes you happy to read back what's already there. So the add is controlled on the type, and then it gives you a view into the data that it has.
Yeah, you could do that, or you could do the, you know, typical thing what we do where we have a derived type from some collection thing, and then you put all the stuff there. That also works.
I mean, is
it's
that
just more heavyweight?
Over engineering the type though?
Yeah, I mean, it is a bit
Slightly.
more heavyweight.
Yeah, I don't think we need a custom.
I mean, I'm even fine with saying it doesn't even have to be a public property either, right? I mean, if you just have a debugger view, that might also be okay, but it's generally weird if you can't read data back. And as soon as you want to do it for logging purposes, yeah, the debugger view wouldn't help you that much. So yeah, having some way to retrieve it, but it could be a method, right? Too. It doesn't have to be even a property, right?
Sure.
If it's mostly for debugging purposes, then we can just make it INU.
Well, but that's the thing that's odd, right? Like, does it make sense to have JSON polymorphism options to be enumerable of derived type, comma, object question mark?
I think it makes sense to query this, like in case one of, like, say some library added some bad hierarchy which allows for code execution or something, and you might wanna remove that hierarchy specifically in that library. Like, I assume we won't have that in the framework, but there might be a library which does something like that. We don't have precedents yet, but I assume it might happen.
We could just have a custom, and that could display a sub relevant values if that's useful for debugging.
Because if removing a type is a scenario, then that is complicated. Again, collection, I guess, gives some of that for free with the. You'd only see it if you cast it as an implement. But,
For this specific feature, though, I can't really think of any scenario that of you removing things.
Right, and if nothing else, you just build a new one of these things and copy everything except the one you didn't like.
But again, if you absolutely do that, then cast I collection and go nuts.
Well, yeah, that's when we keep it in I collection. But I was thinking we remove the I collection entirely.
Yeah, because if the only reason that we want to show people what's there is debugging, and set a custom debug display property. If we think there's a runtime reason need it, then we add an enumerable property or an enumerate method.
And the custom debugger view might be problematic. I don't know what happens with the existing properties if you specify that you have a. Like the enumerable one, I think, will just remove all the properties, and you have these magic ones, bracket 0, bracket 1, bracket 2, or whatever it is, right? Which is might not be great for this time.
I guess worst case, if somebody's using a debugger, they have a private field. Expand the list that's backing this.
Right. But that's why I said, like, I mean, debugging is one thing, but I think there's a logging scenario, or other things where you just want to like inspect what's already given to you. Or that, yeah. I mean, being able to read information out when you can put it in is generally, I think, symmetrical required.
Right, but again, that's a I read-only collection, I enumerable, whatever seems like that. But that's a method or property on this type. It's not the type itself.
Yeah, I think the thing I would agree with. Like, I think to me, options is if the properties you have here plus the mapping, right? But the object is not the mapping, if that makes sense.
And instead of, depending on what you're backing it with, property could be I read only dictionary. Basically, the type is a key and it's a value. It's an int, a string, or a null.
Yeah, I don't know. I kind of feel that this is very domain specific, and I don't necessarily care very much. I do care about adding more code in these things than what is needed.
Yeah, so I just wrote a comment, I think, and so ignoring this for a second, I guess, Jeremy, you're not a fan of the fluent thing here, right?
I mean, it comes up every now and then. feel like we say we only use it in builder patterns. Is it really required here? And then the answer is no. And then so having that same
We don't have that in
discussion rapidly.
the other JSON options, right? There's no fluent pattern for those, right?
No.
Yeah, I kind of agree with Jeremy that I think I'm not opposed to fluent, but I think we usually do it in cases where it's, you know, obvious, where it actually buys you a lot, versus here a regular add method would do the trick. And it seems more consistent with what we have.
Easily be added as an extension method.
Yep.
Called with and turns the this.
Yeah.
But again, the only thing we won't be, like, what we're missing out together with the Fluent API is type safe, type hierarchy declaration. But again, that being said, can't do that on attribute. I don't know.
Well, you kind of do, right? Because in the attribute, you don't expose the object, right? You just expose int and string, right? And you would do the same here, would just have add methods that takes either nothing or int and string, and then the other one is just an INEMO that gives you back what you put in, so you can't mess it up.
It's just the with becomes add and the type is void, like the same stuff's there. I don't actually understand why the generic one exists.
So it basically incorporates the constraint that the derived type must actually be subtype of the base type. So that's what I meant when I was referring to type safe.
I was gonna say, because I assume your with derived type is gonna check, but it becomes a little weird because now if you have add derived type that takes a type and an int, and you have add derived type of t that takes an int, yes, one of them helps you with the generic constraint. The other one's still callable, derived. So I don't know. I can see some use. At the same time, if it's worth the type.
I mean, there might be some that thing, that the generic variant that was actually concocted in the iteration from last year, and at that time it was actually part of the JSON serializer options API. Given that it has been relegated back to contract resolution, one would argue that it's more advanced use. Generally, you wouldn't be expected to be touching this API in the first place. So perhaps these bells and whistles aren't necessarily needed for something that is kind of advanced enough.
Because you're saying like people just use the attributes on their types.
Yeah. You know, writing your own over, don't generally do that when day-to-day coding.
But you would have to use the resolver and the type info if you want. If you're a derived library and you want to add your own custom type, a base types matrix. Again, feels very.
I see.
Who's doing that? Since the base type needs to know about all the derived types.
Technically, you could write a resolver which like checks your own attribute, basically automatically adds that. So basically, you write resolver which accepts your own attribute.
Sure, but you're still touching these. But again, you're.
Yeah.
By the time you're touching, you're a color. Now.
Yeah.
You're a big boy.
Yeah, like if there were other things in the space that were already generic, so it came with the JSON serialization options. I feel like they have a lot of generic already going on with them, and so you're already in the generic, and it all makes sense. But here, where it feels like this is a minority feature that it just doesn't feel worth the type to me. Yeah, I won't argue too much. I do like things where the compiler helps guard you from doing stupid things, but
again, it's trivial to write this type on your own.
Yeah. Unless we seal the settings type, but I don't think we care to.
So are we saying we don't need the generic type then, or are we saying we keep it?
Don't need it.
Okay. Okay. I think this is all we had then. Let me paste it.
Given that we're redesigning the metadata model. Okay.
Okay, sorry, there's some stuff that I had from my own notes. You already answered. There we go.
Yeah, so I was saying that what is the final shape of the options class we're approving in the end?
So, I mean, I left it here as an exercise for the reader, but I mean, I'm happy because it doesn't seem like we can get anywhere. But I mean, I would probably just say add a property that returns an IEnumable of your tuple. That seems fine.
Okay, okay.
And then have an add method rather than the fluent with derived.
Okay.
That seems a bit more logical to me. I assume nobody has an issue with that.
So is when he comes up with a property or method to integrate the mapping, is that a thing that we're gonna say we'll do over email and then never actually get around to answering?
Yeah, either that or, you know, next day we can have 10 minutes spent on that and then call it good.
Okay. Did we want? I thought we were sort of also trying to get rid of the anything with polymorph in its name.
I think we discussed it, but I don't think we got anywhere with that, right? That was my impression.
Like I'm fine with polymorph attribute polymorphism.
I mean,
options.
The reason why I think I'm fine with that is because I think we have at least JSON derived type that serves as the anchor for people to find docs. And that seems good enough, because I don't think, even if we make the attribute nicer and remove polymorphism from the API surface, I'd have a hard time believing people would just IntelliSense that together, right? You still need to know where stuff has to go, and I think you have to read the docs. Okay. But they at least find.
I'm making sure.
Yeah.
Walk out in mid.
I don't think. Yeah, sorry. There's one thing that I just edited locally. Make this here. Yep. All right. So then, I guess we mark it as needs work, and then
yep.
As soon as you have that, we come back to that, and then hopefully this is an easy one, right?
Yeah. I'm not sure if we'll have enough time, but I guess we can try. Okay, so effectively, this came as a customer. Like, we've had this issue in our own internal converters. Effectively, the JSON reader implementation doesn't currently offer a way to get allocation-free use of JSON strings. Like, you necessarily need to make a call to the .getString method and basically decode whatever underlying JSON string encoding into an actual system.string instance. In the internal converters, where we allocate, where we want to avoid that allocation, we actually rely on a couple of actually public properties, reader, value span, or value sequence. But the issue with these buffers, that they effectively contain the unescaped JSON string, and we have an internal helper method for us, but we're not exposing that for advanced users wishing to unescape the JSON strings on their. So in this proposed API, actually, the first section in the UTF-8 JSON reader actually enumerates existing APIs just to freshen your memory. So we have a read-only span of byte. So let me rephrase this. JSON strings can either be contained in read-only span of byte, or it can be contained in read-only sequence of byte. And which property to look up is by the has value sequence property. And furthermore, we have a value that signals whether the values actually escaping. So the proposed APIs for the JSON reader is a couple of getString methods that accept span buffers in which the reader will actually copy the unescaped string away. You can see here that actually the span parameters new a construct introduced in #11, the scope modifier, which specifically intended for by restructs accepting stack allocated buffers. That is currently possible current versions of C#. So introducing this scoped modifier should make that possible because we're not actually storing that buffer into the fields in the struct.
So it wasn't a typo. I was like, what is this new keyword I've never seen in my life?
Is that feature net standard 2.0 compatible?
Excellent question. I suppose it should be. Like, I believe that this is only a language feature. I had a chat with Jared about it, and they're explicitly intending this modifier retrofit existing. Like, that's one of their design goals. Because we have a bunch of methods on restructs, I guess, that accept spans, and currently it is effectively impossible to safely pass stack allocated spans to. You can do it unsafely, of course, but you know, the compiler, I guess, is being overly conservative in this case. The scoped modifier would, I guess, add validation, making sure that the particular argument would escape its scope.
Yeah. So the question is just, I know you're a net standard 2.0. It's is adding this keyword here going to cause life to go.
That is to be. For what it's worth, we don't have C#11 yet. Like, that feature is per Jared, they're in the final stages of design. They're very happy with the design, but it's likely that might still change. So we are. The idea here is that we ship the APIs without the modifier, and we can retroactively apply it once C#11 becomes available. But the main takeaway here is that we feel that this constraint on behalf of the C# compiler is not blocking us in any way from adding these features.
I mean, in general, we could also just say this API is only available on .NET Core 7, right? I mean, there's nothing really preventing us from doing that. We have done this before in other places.
Yeah.
It depends on whether the customer's running .NET 7.
Well, I mean, that's true, but I mean, like, if we believe in the customer scenario, then we can just tell the customer, yeah, sorry, you don't get it on your ancient version of .NET, but we have it on the new one. But I mean, it's more like, do we believe the API has value, right? I guess. Which to me seems yes, but that's, I think, kind of like, you know, orthogonal whether we can make it available for .NET Standard 2.0. But
so, I mean, what I was going to ask, there's kind of two here. One, scope to C#11, but also officially speaking, it's only officially supported on C#11 later, regardless of whether or not it's just language in sugar. This shouldn't require runtime, so it should technically work down level, but officially speaking, that's unsupport. But also on top of that, what's the, like, so the language today won't allow you to pass in span to this because there's the chance it won't let you pass in spans because the chance that the ref struct could capture it. So what's the expected way that, assuming that we expose this and the language didn't ship scoped whatever reason, what is the expected way that users are going to be able to utilize this API without scope?
So they should still be able to do that, but they would need to do it unsafe.
Well,
So they would need to get a pointer to the span. They need to fix the span, get a pointer to it, and
this is just sort of, instead of putting it as an instance on F8 JSON reader, should it be JSON encoded text taking F8 JSON reader and a span destination? It can say
that would trigger the same value error.
Well, you can make an extension method, and that does not trigger the error because then it's an extension method and it can't be captured.
But then you're copying the entire reader.
Well, you can do a ref read only. You can take the UTF JSON reader as in
But
the
it is
extension
a
method.
mutable structure that result in copying in that case.
Yeah, would want to be
No,
ref
no.
because to have moved to the next value.
Oh, okay. So
Unless it doesn't.
actually it's the underlying.
Kind of has to, right? Because it advances.
Or does it?
No,
Does
it
get
doesn't.
string?
It doesn't.
Oh no, because you have to call next
Right.
or whatever.
That's what I thought. So if it actually doesn't mute, then you can make these read-only extension methods, and as long as you don't call a mutating API, or you only call APIs that are appropriately marked as non-mutating, then there will be no copies, and it's safe. And the implementation can make that guarantee. And so you can safely expose as an.
Yeah. So
Sorry.
to the thing that Tanner's mentioned, like when you call getString, was the method that you called immediately before this move next? So like you have moved on to the string, and now
Correct.
you're calling getString. Okay. So that means that we already know where the end of the string is because the value sequence or value span has to contain information.
Yeah, I mean, it looks like right now F8 JSON reader literally never use the word read-only in public API. It could certainly enhance itself with marking which members are, aka everything, are not mutating.
So what happens when the value spans multiple like elements in the sequence?
Then value span is empty and value sequence is not, and has value sequence is true.
Like, but how do you get to the next thing in the value sequence? Is it a sync operation or an async operation?
It's all in memory. It's all synchronous.
I see. So basically the expectation is if you call getString, we would potentially enumerate a sequence in order to fill that destination buffer.
But that sequence is already in. So you would be enumerating data that's already in memory. There's no network hit here.
So what I don't understand is like what does this require the scope thing? Isn't basically the semantics you give it a span, we fill it, and that's the end of it?
So I could probably not do this. So for the purposes of this API review, I think we can forget about the scoped modifier. I think we could just do the APIs, just taking regular span parameters, still making them instance methods. I guess the reason why I added here is to spark this because the C# team the C# team are confident that we can retroactively apply the keyword and therefore make passing, for example, stack allocated spans safely.
Oh,
right,
I see. I see. So basically, if you pass a span to a ref struct, that ref struct could capture that span. So the compiler will not let you pass in a stack allocated span right now.
Would it employ the same guard on the current method if the method was declared read-only? Because if assuming you followed the rules, it means you can't have captured the span because you were read-only.
Yeah. So I was going to ask that because then now you have to make value as safe read-only, as value sequence read-only, value span read-only, value sequence read-only. Like it goes.
Oh, literally everything read-only.
Yeah.
They're all just saying what state it already has. So like this is we've not been following our guidelines read-only because I think this may have gone in only members in the.
I think you're right.
But like it's possible that right now, if we just declare this as public read-only talk about the return type, get string of the span, that the compiler would know basically it's already scoped, you can't capture it. They may not have, but we should probably, if it's not mutating, we should declare it as read-only.
Yeah,
We'll do that.
I agree with
Also
that. This
fix
whole
up.
problem goes away at that
And
point.
maybe also just give you a blanket of to apply it to everything that's not actually mutating.
And the modifier goes before the semicolon or before the return type?
It's before the return type.
Yeah, I cannot remember. I think that, yeah, that would make the most sense. But I think I saw it at some point at the end, but maybe that was just Jared sketching stuff on the whiteboard.
So
So the compiler, if the method is read only, it does assume that it can't capture. So that would cover the.
Nice.
Okay.
But if I was going to say, if it didn't, then there's the option for extension method. And for .NET Framework, there's the option of taking in an array, and then a user can use an array pool to avoid the allocation. Still not necessarily free in the worst case, but at least it still works.
Amortized free.
And so there are a few options. And if since the read only works though, then just taking a span, having the method read only, which means that it will never mutate now or in the future, means we don't have to consider scoped. And everything's fine.
So since these aren't try, how does somebody have an idea how big of a deviation?
So, excellent question. So the reason why I didn't add try method proposal is that effectively we cannot really know the precise length of the final unescaped string unless we iterate through it, unless we run the entire unescape logic over it. So effectively, I've applied the same constraint that currently exists in our internal unescape routine. And I guess I want your opinion on whether we should do that in the public APIs. Specifically, if the length of the buffer is smaller than the actual escape string, then it will always throw. So effectively, onus is on the caller to validate that the buffer at least as large as either value span or value sequence. Trying to.
Now, one interesting thing about that logic is it could have succeeded. Like you could have passed an appropriately sized buffer. It's just we pessimistically said it might not be small enough or it might not be large enough, but we didn't actually do the logic.
Yeah, so if the answer is it throws for anything length is smaller than value span or value sequence length, whichever is bigger, then sure, that's how they knew. That was the pre.
Yeah. It is a bit strange though to me that would be the case, just because we're not normally in the business of failing operations that could have succeeded had we just tried.
But I mean, we'd need to clear the buffer if we failed, though. So that adds up.
Well, only if you mutate anything.
What about the destination buffer? You will have written things by the time that you find that you've run out of space.
Right, unless you do a pre-validation step.
I mean, I feel like while I was always a fan of if something goes wrong, clear it, that we don't do that now as a general rule unless it's security sensitive API. Granted, any API could be security sensitive, but I think we've only been doing it in things like you're actually crypto, and so we're going to say we're not going to give you partial data.
Right, and I think try-format APIs in general, they return the number of bytes written even in the case of failure because it's possible that they partially mutated as they were iterating through. Like
they return false and out something other than 0?
Mm-hmm. Because you might have a formatter that has to format values because it's a complex expression.
Okay. Pretty sure our guidelines on try write say if you return false, you should always out 0.
Yeah,
Whatever.
unless the return value is useful somehow.
Right, but that's also impractical for a lot of APIs. Consider, for example, just as a simplistic example, the complex number. If you want to try format a complex number, you have to do 2 sub format calls, once for the real, once for the imaginary, and then you've got the open and closing part for the collection, and then the separator. And so it is impossible to provide a try format API that writes nothing, and therefore works as an allocation-free try format API as the user intended.
No, but
without writing nothing.
My understanding of our current position on span writing things is if you call a try write method and it returns false, you assume your entire span has been obliterated, and it tells you 0 because you can trust 0 data that's in it. I believe that is what our convention is. It doesn't. We don't care how many bytes we actually wrote to your destination. Your destination is now garbage.
Because there's no way to restart the operation from where it left off, so the out parameter has no value, so it may as well just be 0, or has no purpose.
Right, but that's less useful than saying that how much of the buffer was actually trashed, and therefore how much of it you can trust versus not.
Again, I'm just what our guidelines say is if you're try write, you should out 0 if you return false, and that the caller should assume that the entire span was obliterated. It does not necessarily preserve its contents.
Yeah, I don't really want to get into the habit of having APIs return like this is how much of the buffer we obliterated, because that puts a huge burden on the people implementing those APIs now. Because they could use a buffer. They could use a buffer as scratch space.
Yeah.
Right, but if you're doing something interesting with a buffer, for example, re-clearing out in between or anything else, it's a way to save cost by actually saying, here's how much I legitimately trashed versus here much I could have hypothetically trashed. Because most of the time you're passing in a buffer that's optimistically too big.
Yes.
Yeah.
And it's very bad to say I've actually trashed the whole, maybe 4 kilobytes when I only actually wrote, let's say, 1 byte.
I mean, if a particular API wants to have a separate contract saying I out this, that's fine. It's just I really don't think we should make it a convention that people do that, because like now, if we make it a convention, now this API has to follow it too, which is just weird.
But anyway, as for the return type question, why would this out the int instead of just returning it?
It could be returning it, yeah. I guess you can tell that these used to be try methods.
Right, so for tries, it would be the return goes to did the operation complete. But we span writing non-tries, the general convention is just return the number of units written.
Yep, agreed.
And we have, for some APIs, we return -1. For some APIs, we throw an exception. If you look across memory extensions.
The guidelines suggest it should be an exception.
Yeah. I would be fine. I would be fine with you throwing an exception here, or whatever you want.
Yeah, I mean, there's another point to be made here that ultimately I can't think of what a valid fallback would be if a try method would return false in this context. Like, there's no, realistically, there's no way you could resume. Like, do you allocate a new buffer and try again from scratch?
Again, that's the pattern with a try write is, it's you do I opportunistically had 14 bytes left. Can you write it in the 14 bytes? It says false. And you're like, fine. Now I'm going to go, either double the size of my buffer and try again, or if there's a heuristic method that I can fall back to get me the number in, one more call, then do that. Whether it be an exact match or this is guaranteed big enough.
In any case, and that's kind of deriving from the patterns I've seen in converters, like there's generally an upper bound in terms of what the size of a thing is. And it's usually small. Like, for example, there's a version converter, and in version converter, you have a maximum character number of, I believe, 4 times plus, the maximum number of digits per version number and the dots in between. In date only, it's 10. So the common pattern in these types of allocation-free converter implementations is to just stack allocate using that upper bound and pass it in, make a check that the value span isn't actually of length 10,000, and that's it.
Mm-hmm.
Yeah, but the tries are, mostly they're in the realm of composition. Of you're a try, and you're just going to keep saying, I don't know, like up to this point we've written 112 bytes, so I have 28 left. Can you do it in the 28 I have left? And it says no.
Okay.
So now you just return false from the composite operation, and the caller says, okay, I need a bigger buffer now.
Yep.
So
this is where native APIs, I think, have a leg up on what we do in .NET, because they typically expose it as taking in a pointer and then taking in a ref count, where the ref count specifies how big the buffer is, and on failure it will return the number of bytes necessary for the buffer. That way you can opportunistically do one call, but worst case do two calls, where you definitively know the exact size you need for the second call.
yeah, again, that one is, I feel it's a little inconsistent. I know a lot of them do that if you pass in null as your destination buffer. I think that some of them, if you give them non-null, it fails and doesn't tell you how big you needed to be, because that wasn't, like, basically they wrote two operations and it was, did you pass null or not, determined which one you did. I feel like the crypto APIs, which are what I call in Windows, are very much, if you pass null, we will tell you how big it needs to be, or a number that's at least big enough. And if you don't pass null, then we tell you you didn't give me enough memory.
Yeah, I think that's where the crypto APIs are special. I know most of user 32 and stuff do the opposite, where they do exactly what you said for null, but non-null they'll tell you how big you need anyways.
I mean, if you wanted to do the easy thing and have the user not worry about how big a buffer they have to pass in, the normal string returning API is right there.
Right. And again, what we would have in this case for, try get string would just try and do the work without looking at bounds, unless it could prove a lower bound, like that JSON escaping, that assume literally everything is escaped. So that's going to be what, 6 characters go to 1. And then you'd be like, okay, you're less than 1/6 of this span. This will not work. I'm going to abort early. And then it'd just be like, whatever, just try it. Nope, it returned fail. So give me a bigger buffer. And how big of a buffer do I need to get? Well, it will never get smaller. Sorry, it will never get bigger. So value span.length. If you give me that long, it's guaranteed to work.
Yep. On an unrelated note, how concerned are we about authoring a getString overload that returns an int?
Normally you wouldn't say getString. Normally you would say like copy string into or something like that.
Okay.
I mean, I think to me this looks exactly just like the normal spanification. Yeah. Get string, try get string, and get string being the I throw if it's too small.
Okay. A possible argument against using getString in this case is my expectation of an implementation of these methods would be to throw if JSON token type is null. That is not the case in the existing getString overload. We tolerate null token types. We would not be tolerating null token types in the spanified overloads.
When you say null token types, you don't mean the literal null. You mean
the JSON null.
Yeah.
Okay.
That the JSON said literally in ULL.
Okay.
Yeah. I mean, so we, instead of get, this could be unescape. So it's unescape string, and then it throws if it's not a string. You don't need to unescape null.
Yeah.
Because I agree with you that that's
easy?
more of a behavioral difference across this overload. Of one of them works with null and the others don't. So that does suggest they want to be a different method group.
I assume that UTF-8 JSON Reader has a fairly easy way to check for the null literal before calling this API, if you really care.
Yep.
Yeah, it's like there's a token type property or something, and it would tell you it's null or string. Or I think property name is also valid here.
Correct. Yeah.
Could be.
So I should clarify that the proposed APIs would work in string and property name. So anything that has quotes.
Yeah, I mean, since the thing that they're really basically calling is JSON encoded text.unescape, I think unescape string is a
I
good
mean,
name for one
it would work
differentiate
even
the
if
null behavior.
it would work even if unescaping is not required, and it would be useful even if unescaping is not required. So how about something like copy string?
That's fine with me.
Yeah, if we are talking about taking a destination buffer, copy to is normally the pattern that we use.
Do we need to specify that it's unescaped, or so
I wouldn't, just because get string doesn't say unescaped. It's just like,
yeah,
it's the string value. However it was represented in the payload is irrelevant.
Yeah.
Like if you want the raw bytes, read-only span and read-only sequence are right there.
Yeah. So I know I have a general disdain for things being UTF-8 just because they say span of byte. So should we have copy string and copy string UTF-8?
I mean, that's not what we did for the encode APIs.
Yeah, the actual type itself contains UTF-8, so I don't know if putting the suffix is useful.
That's fair.
So I also didn't quite understand what's wrong with the unescape one. Like we want to call it getString. Is that what the?
Sorry, are you talking about the third API on there, the very bottom one?
Yeah, it's not the one that you talked about. I thought you talked about.
No, we're talking whether getString should be named unescape. And actually, we recently had a PR in SignalR using UTF-8 JSON reader. We were trying to like intern strings, and like one of the subtle things that was wrong in the initial iteration is that like when we were interning, like we weren't unescaping first because like it wasn't obvious that getString was doing that unless you like looked at the source code.
Yeah.
So there's something to be said about being explicit, maybe, but like getString already exists, so there's something to be said about making it clear that these behave the same way.
Yeah. Yeah. So the final method.
So before we go there, like, do we make then any decisions on changing it in any way? Like, are we still calling it getString, or are we doing anything?
I think it's public read-only int copy string.
Copy string.
Yep.
At least that's the shape it had in my head. And Eric
Yeah,
said, yep.
I do prefer copy over get.
Yeah, I would say if it didn't differentiate on the null token, I would say it should be get because it's just the spanification of the current one. But since it does have a different behavior, then it should be a different method group.
So what is the behavior of copy string when the value is null?
If the token type is null, it throws. Why did you call this method?
We have other APIs that do that. The throw if the underlying type's not right.
And the existing getString just returns null, presumably.
Yeah. And I believe it throws if the current token type says number. So it has places where it'll throw if it's object or array, and so it just says null is a valid string representation.
I mean, does it have
these
to
others
throw?
are like?
Sorry. I mean, like it seems like it could just return nothing, right? It could just say bytes written
it
0.
throws to tell you you're using the API wrong. String was not a valid answer if you're looking at an array.
You wouldn't be able to distinguish between the empty string and null. So I think it's probably preferable if it's through.
I see.
-1. No, just kidding.
Yeah, I'm not sure I understand the rationale why there can't be the same method group purely because of the null handling, but I think copy string is also fine.
Yeah, well, I think it's just weird because if you had, your current switch that says if it's null string or property name, then call get string. And now you're spanifying that. Now one of them now this moves into throwing if you saw the null. So it's not a clear, like they behave differently and not just in what they return.
Yeah, they have a different set of preconditions, so I guess that necessitates a separate name.
Yeah, but like you can't really drop it in anyway, right? Because I mean, presumably when you get a string out today, I mean, you know, you pass it around as a string, right? Now you get a span, so you're not going to pass this around as easily anyways, right? So
I mean, even if we tolerated nulls, I still take issue with get string, because my expectation is that the result of that get would be in the return type, which
Yeah.
is clearly not happening now.
no, I'm not pushing back on the rename. I'm just saying if the only reason we're renaming it is because of null behavior, that seems a bit excessive. If we're saying, well, you know, we're clearly doing a copy here, so copying makes sense as a method name. I mean, that one I don't have any issues with.
Right.
Fair enough.
All right, then JSON encoded text.
Yeah, so I guess that's just exposing the underlying low-level unescaped functionality as a very basic thing that, you know, takes a read-only span and a span destination and same signature. I guess we could change that as well to return int, but it's useful in its own right, especially if you know what you're doing. And I should point out that the copy string implementation of the UTF-8 JSON reader would involve a bit of buffer pooling if you're dealing with read-only sequence. And for folks wanting to avoid that scenario as well, they might want to write a bit more involved code that does unescaping directly on, you know, whatever buffer you're giving it.
So JSON encoded text is called encoded and has methods called encode. So it seems weird, a little weird to me. Like I get it, but it's weird that it would be encode and unescape.
Yeah.
Unescape's
clearly
the better name though.
Yeah.
It's clearly a helper method that doesn't have anything to do with the JSON encoded text struct, which I've incorrectly rendered a class in this proposal. But then again, I don't think it would fit with UTF-8 JSON reader or some helper class. It is concerning JSON encoded text specifically, so.
That's fair. Should it also, excuse me, do UTF-16 to UTF-16, or just wait until somebody actually asks for that?
That would necessitate, I'm guessing that would, I guess we could write a second implementation that does that on char. But
I mean, you could kill the perf and
yeah,
send it to UTF-8 and then unescape it and then send it back. But
yeah.
So regarding that API, because that's a static API, you're probably also going to want to check well-formedness as you go in.
Well-formedness in one sense.
So for example, if somebody passes you /u garbage, something that's not representable in any UTF, right, whatever, what do you do?
Yeah.
I would say probably throw if you see it. Like throw if you see something that's not escaped properly. But yeah, I probably wouldn't go so far as to say, like, if you see a literal new line character, for instance, throw. Like that seems a bit excessive.
Yeah, that's a good point actually, because the internal method is obviously making assumptions about the input.
Yes.
Yeah, because the reader would have already validated that the escaping syntax was legal.
Yep.
Yeah.
Oh.
Yeah. When you have a static API, you have to assume that people will just call it with garbage.
Mm-hmm.
I just didn't realize UTF-8 JSON reader had already validated the string at that point.
Mm-hmm.
Yep. Move next would have returned false. The JSON is invalid. We're done. Or thrown something.
Yeah. So if somebody, so I would say, I guess if somebody passes in a UTF-8 value, for instance, that has, again, like a literal new line byte inside of it, like I would just ignore that because, like, whatever. But if they pass, for instance, /x, that's invalid, that would fail. if they pass /u d800x, that would also fail, and so on.
Yep.
Because there's literally nothing that can get represented as.
Yep.
So is this different? So we call it unescape, right? But why wouldn't we call it decode? Because decoding is different from unescaping?
Here they're the same.
I feel
Yeah.
like when I'm like write a JSON literal or a JavaScript string or whatever, right? Like I'm not encoding things, right? Like the unescaping is kind of irrelevant, right? Like we're asking, should we do it for both the UTF-8 and UTF-16 encodings? Most people think of encodings, they think of that. They don't think of escape sequences. So like, it's a better name, unescape. It's on JSON encoded text, which is kind of unfortunate. I don't know, not that bad. It's like, yeah, there's no such thing as like a JSON encoding. It's like JSON escaping, really, and unescaping.
Yeah, well, because the JSON encoded text, the reason I asked about UTF-16 is because the type in its encode methods can take UTF-16, and part of what it does is transcode that to UTF-8 while escaping it. And
I think we should do that, because otherwise people will do the UTF-8 and back to UTF-16 thing themselves, right? People want this, presumably, for .NET strings. They probably get these strings other ways.
Yeah, I mean, certainly we can approve adding a, public static int unescape UTF-8 UTF-8 and public static int unescape UTF-16 UTF-16. I don't think we need to do the full matrix, but like just because we add it or just because we approve it doesn't mean that Eric actually gets around to writing it.
We do accept PRs, as it turns out.
So there have been requests to add decode functions into Stew for a while, System Text Encoding's web, because that's where the encode functions are. For JSON, I guess it would make sense to add it there if we really wanted to do it there. HTML, not quite so much, which would probably cause an asymmetry. So maybe it's a good idea not to put it there. Maybe it's a good idea to put it here instead.
I mean, presumably this does the inverse of what the constructor is doing, right?
Kind of. The constructor is querying Stew as to how the encoding should be performed, and this method is looking only at the JSON spec itself to see how decoding should be performed.
Yep.
And there are assumptions made about the input. For instance, one of the assumptions is that I had mentioned a few minutes ago is that the input actually is like a real JSON string that just happens to have escape characters.
Yep.
I see. So like it is different from the web encoders then?
Yeah, so the web encoders assume that the input contains literally any arbitrary garbage, and that it needs to be wrapped inside of an envelope to make it appropriate for sending over the wire, wrapped in JSON, HTML, URL, what have you. This basically says we already know that we've received like a string token from JSON, and we just need to make sure that all of these special like / whatever transformations that you did are undone.
But where does it say that? Because you just pass in an arbitrary read-only span of byte, right? It could be literally anything.
Could be not even text.
Yeah, it could be like
True,
a byte.
and that's kind of why I'm saying like for this scenario, given our use cases, I think that's not a huge deal, and you should probably memorialize the fact that I'm actually saying this. Because normally you've seen my arguments about string validation. In this particular use case, because you are getting it back from, for instance, the UTF-8 JSON reader, there are assumptions that are valid to make, I think.
Well, but that's not true. Like, I think as the static method, I think it should probably have to walk UTF-8 well-formedness, basically use the rune walker thingy, etc. it can technically be implemented as there's a non-public version of the method that the UTF-8 JSON reader calls into, because it knows that getString has already been validated, so it can call with a hidden skip validation. But I think the public method, especially because UTF-8 is not a type, it's bytes. So I don't think it would be consistent that if you read a PE file and run it through escape, that it works unless it happens to see a backslash followed by things that aren't a U and 4 numbers. Like,
yeah, I'm kind of wondering, given that our intent, like the intended usage for this static is to pass in value span, essentially. So I'm wondering, you're right that we should, given that this is a public static, we should add validation, but I'm wondering if that kind of defeats the purpose and we should just ship the copy string APIs on UTF-8 JSON reader and hold off on the static.
I mean, where do you get the UTF-8 value from normally? Do you get it from value span, or do you get it from calling copy string?
copy string will give you a value that's already unescaped.
Yep.
So you wouldn't need to call the new API. I think really the use case is if you had value sequence and you wanted to do something different than what copy string is going to do inside.
Gotcha.
But yeah, I think maybe punt on the unescaped, because there's a question of should it live on JSON encoded text in JSON, or should it live on the
JSON reader
JavaScript encoder in Stew, and then the UTF-8 versus UTF-16 and decode versus unescape. Like it's got a whole bunch of questions, and even though it looks really simple, I think we would end up debating that for like an hour. So yep. I recommend cutting it from the current proposal and bringing it back later if desired.
Yep, sounds good.
Probably should have asked this question 20 minutes ago. That would have really helped the conversation, but hey. So then, does this echo what we said? Did I forget something?
We're cutting the static.
So cut the bottom type
sorry.
modification.
I only expressed it in text form. That's fine.
Cool.
Happy then?
Nice.
Cool. Then have a nice one, everyone.
Yeah. Thanks, everyone.
Thank you.
Ciao.